Alright, so this is Mr. Liao, and welcome to Chapter 4 of Algebra 2 Trig. We're going to try these online notes, and hopefully you can follow along. Today we'll be looking at Section 4.1 Polynomials. Now, the way these are going to work is that obviously I can't answer your questions in class, so if you have questions, write them down and you can ask them in class tomorrow. I'm obviously not going to wait for you to do the examples. I'm going to stop maybe for a second, give you time to pause the video, and then you can work on them yourselves when you're ready to check your answer, or if you're stuck, that's when you resume the video. Okay, so here we go, section 4.1, and hopefully you all can access this. Today we are going to ask, how do we simplify, add, and subtract polynomials? Now, if you look at page 167 of your book, you're going to see all the definitions that are on your note sheet. I am not going to go over all of them in detail. A lot of them are things you should know. One of the things I will go over is this concept of degree. Degree generally refers to the number of times a variable occurs as a factor in a monomial. So a monomial, as you can see, is a constant variable or a product of a constant and one or more variables. So, for example, in the monomial 3a cubed, the degree for a is 3. The degree of a monomial is the sum of the degrees of the variables in the monomial. So, if you consider the monomial 4g squared h cubed, it has a degree of 5 because you add the exponents together. You add the 2 and the 3, and that gives you a 5th degree monomial. So, again, to find the degree of a monomial, add the degrees of the variables in the monomial together. And they don't even have to be the same variable. Just add them up. A non-zero constant has degree 0. So a constant, as you can see in the first term on page 167, is just a number. There is no variable. And if you think about 0 degree, it's basically, for example, a to the 0th power or x to the 0th power, which is always going to be 1. So think about that as a non-zero constant, and non-zero constants have a degree of 0. The degree of a polynomial is the greatest of the degrees of its terms after it has been simplified. Now, if you look in your book on page 167, you'll see that a polynomial is a monomial or a sum of monomials. The monomials in a polynomial are called the terms of the polynomials. So, the degree of the polynomial is going to be the greatest of the degrees of all the terms after it has been simplified. Simplified is another way of saying all like terms have been combined. So, in the example on the screen, x to the fourth minus 2x cubed y squared plus 4x squared y to the fourth minus 3y to the fifth plus 7, the degree of the polynomial is 6 because the 4x squared y to the fourth term has a degree of 2 plus 4 or 6. If you look at all the other terms, the x to the fourth is only the 4th degree, the x cubed y squared is only 5th degree, and this is also a 5th degree. Of course, the constant is a 0 degree. So the degree of the polynomial, you take a look at the monomial with the greatest degree. To simplify polynomials, it's just like when you added x's together and y's together, but you couldn't combine x's and y's and x's and constants. To add two or more polynomials, write their sum and then simplify by combining similar terms. So you can combine x squareds, you can combine y squares, you can combine x squared y squareds, but you can't combine x squared y squared with an xy, for example. To subtract one polynomial from another, add the opposite of each term of the polynomial you're subtracting. Don't forget to distribute the negative sign. You are subtracting what's probably going to be in parentheses. Don't forget that negative a parenthetical is the same as distributing a negative 1. We'll take a look at an example of that in a moment. So in example 1, we have the polynomial 3x minus x squared minus 9 plus 2x squared plus 2 minus 5x. We are asked simplify and then give the degree of the polynomial. So the first step you'll want to do is identify like or similar terms. You're going to group them together. So here are a couple ways to do it. The first thing you might want to do is to either underline the terms or circle them so that like terms can be combined. So the first thing I did was underline the negative x squared and the 2x squared. You will also notice that you can group the 3x and the negative 5x over here. Finally, we have a negative 9 and the 2 representing the constants. So to add these together, or to combine the similar terms, you would basically take each term and add it with its other like term. So negative x squared plus 2x squared is x squared. 3x minus 5x is negative 2x, and negative 9 plus 2 is negative 7. So you're going to want to rearrange it if you want. You don't have to do it. It's just something that might make it easier for you. But what you'll want to at least do is identify similar terms and combine them. So negative x squared plus 2x squared is 1x squared. 3x minus 5x is negative 2x. Negative 9 plus 2 is negative 7. And we still have to answer what degree is this polynomial. It is a second degree polynomial because the highest exponent for any monomial is 2, this x squared term. Example 2. We have x squared y squared minus 8xy to the fourth plus 2x to the fourth y plus 5x cubed y cubed plus 2xy to the fourth. And again, you're going to want to group similar terms. Now you can do this on your own, and I'll give you a moment to do that. If you want to pause and try it, go ahead. I'll be here when you get back. Alright, so if we combine similar terms, there are the colors that I've identified similar terms. Now remember, the x and the y exponents have to be exactly the same in order to group the similar terms. So if we rearrange our expression, we have x squared y squared plus 2x to the fourth y plus 5x cubed y cubed minus 8xy to the fourth plus 2xy to the fourth. And the only two terms you can combine are these blue terms on the very right. So your solution is 2x to the fourth y plus 5x cubed y cubed plus x squared y squared minus 6xy to the fourth. Now, we still have to answer what degree this polynomial is. What degree do you think it is? Well, it's going to be this term over here, the 5x cubed y cubed term. And why is it the degree of the polynomial? Because the sum of the exponents, x cubed y cubed, equals 6, and that's the highest in the polynomial. The x to the fourth y is only 5, this one's only 4, this one's also 5. So this is a 6th degree polynomial, and the key term is 5x cubed y cubed. When writing polynomials with two variables, write one of the variables decreasing in degree and the other variable increasing in degree. And that is merely for style, and you're going to want to get used to this because this is how it's going to be written. So if you take a look at this expression, I'm using x to the fourth here, and I'm decreasing my x exponents as I go from left to right. On the other hand, the y's are getting bigger. Y cubed, y squared, y fourth. Well, not quite, because this isn't totally in order, but you're going to want to pick one of the exponents to be going down and just fill in the others where appropriate. Alright, let's go to example 3. We're going to add negative 3x squared minus 4x plus 9 and 2x cubed minus 4x squared minus 5. So, there are a couple ways you can do this. The book likes to have you line them up. So you're going to line up like terms. So the first expression is there. The second expression goes there. Now you notice that I've lined up the negative 4x squared with negative 3x squared and the negative 5 with a positive 9. Those are because those are like terms. And now it's just as simple as adding two equations or two expressions together. So you're going to get 2x cubed minus 7x squared, which is these two added together, minus 4x plus 4. And that is the answer. All you have to do is add them up, but make sure you combine the like terms. If you don't want to do it that way, you can do it what I did before, basically identify like terms and then add them up. So our first term is 2x cubed. We take care of that. Now we look at the x squared terms. We have a negative 3x squared and a negative 4x squared. You combine those and you get negative 7x squared. We've taken care of those. Now we move to the x values. There's only just the one, negative 4x. We stick that on. And finally, we have the constants, a positive 9 minus 5, which is plus 4. And that takes care of the constants. There is your expression. So you can do it either way. You can line them up, which might be easier to visualize, or you can kind of do it this way. Now when you do these, make sure you're careful to copy the problems down correctly, because if you copy one exponent wrong, it'll mess up your entire answer. Finally, we have example 4. Subtract 3x squared plus 4x minus 5 from 2x squared minus 9x plus 7. Alright, so you can line them up this way. Remember, when you're subtracting a from b, you're basically doing b minus a. So, we're taking 2x squared minus 9x plus 7 minus the quantity 3x squared plus 4x minus 5. Now, remember when I said do not forget to distribute the negative sign. So what you're going to do is take this negative sign and change the sign accordingly, and you're going to want to add them. It's just easier that way because adding is more likely that we'll get the right answer and less likely we'll make a mistake. So if you distribute the negative 1, you get 2x squared minus 9x plus 7 plus a negative 3x squared minus 4x plus 5. And just like before, all you do is combine like terms. Your answer is negative x squared minus 13x plus 12. So these are not very complicated problems, and they're not designed to be. These are just an introduction to how to add and subtract polynomials. Now, the homework will have most of the problems that look like this. You might have to do some distributing, you might do some factoring, and there might be one that's really hard where you have to figure out the coefficients, but they're not something that you won't be able to do. If you have any questions, please write them down and we'll go over them in class tomorrow. Tomorrow I'll also give you the classwork assignment. You'll be expected to do most of it during class tomorrow, and I'll be available to help you with any problems. Alright, that's section 4.1. Chat again soon.